Click the bell icon to get latest videos from Ekeeda.
Hello friends, so today we are going to do a numerical wherein we have the value of the core refractive index. We also have the value of the angle of acceptance, and we need to find out what is the allowed value of the refractive index of the cladding. Now let us see what this problem is like. Here's the problem. An optical glass fiber of refractive index of 1.5 is to be clad with another glass to ensure internal reflection that will contain light traveling within 5 degrees of the fiber axis. What minimum index of refraction is allowed for the cladding? So what we mean out over here is this: we already know the refractive index of the core. We already know what is the angle of acceptance for this particular fiber optic cable. We wish to find out what is the refractive index of the cladding so that all this particular data fits well. Now let us look how we can do this particular problem. First of all, let us look what is the data. So what is the data out over here? The data is the refractive index of the core, which is mu1, which is equal to 1.50. Second is the angle of acceptance, which is nothing but ACC, which is equal to 5 degrees. The angle of acceptance is 5 degree. And what we are supposed to find out over here? We are supposed to find out the mu2. So this is the main thing that we have to find out, what is mu2. Now, based on this particular data, the formula that we need to utilize over here is, so what is the formula that we need to utilize over here, right? So the formula that we need to utilize over here is numerical aperture is equal to the refractive index of the medium in which the cable is kept multiplied by the sine of the angle of acceptance. In this case, mu0 is 1 because the medium in this case is nothing but air. Do we know the numerical aperture for this? We do not know the numerical aperture for this. But do I know what is the sine of the angle of acceptance? Yes, I know the sine of the value of the angle of acceptance. So let us start from there. So from here, you can say that the sine of IACC is equal to the numerical aperture divided by mu0. Mu0 of course is 1, hence the angle of acceptance ICC is equal to sine inverse of the value of the numerical aperture divided by your mu0. So the value of the angle of acceptance turns out to be sine inverse of the numerical aperture divided by your mu0. But do we know what is the numerical aperture? No. The normal definition for the numerical aperture is square root of mu1 square minus of mu2 square. But do we know what is mu2? We do not know what is mu2. So do we have an alternating way of finding out what is the numerical aperture? Yes, we have that. And we know that the numerical aperture is nothing but mu0 multiplied by sine of I angle of acceptance. So let us do that. So your NA is equal to sine of angle of acceptance, wherein I have assumed that the refractive index of the medium is 1, and hence we are not writing it down over here. So this works out to sine of 5 degree, and this turns out to be, that is the numerical aperture turns out to be, so the numerical aperture turns out to be 0.087. The value of your numerical aperture is now turning out to be 0.087. It is now that we can actually utilize this particular value and find out what is the value of your mu2. Let us do that now. So your numerical aperture is turning out to be square root of mu1 square, which is minus of mu2 square, right? We take the square of both the sides, which turns out to be na square is equal to mu1 square minus of mu2 square, and hence your mu2 square is actually equal to your mu1 square, right, minus of na square. And this turns out to be your mu1. You already know this value. The value of the mu1 is nothing but 1.5 square, and the value of the numerical aperture you have just now obtained, which is 0.087 square of this, and hence your mu2 will be equal to, so the value of the refractive index of the cladding is now working out to 1.49. So this is the value of the refractive index of the cladding. Now please note over here, students, that this value mu2 is smaller than mu1, which of course should be, this is your mu1 value, which is 1.5. This will of course be less than this particular value, that is 1.5. And that is one of the criteria for observing total internal reflection in a graded index optical fiber. Sincere thanks, students, for watching this particular video. Stay tuned to our channel Ekeeda and do subscribe to our channel Ekeeda.